Assalamualaikum and hi everyone. We will present about the instrumentation for process control. We are from the group 6. So this is our group members: Nur Iman bin Baharin, Recher Egoh anak REPAI, SHANKAR anak SUBRAMANIAM, Tan Kida, and last Muhammad ZULHAZRI bin ZAKARIA. So as you can see, this is the design of the PLC programming for process control with efficient and sustainable operation. Then I will pass to our group members for the explanation.
Good morning to Dr. and my fellow friends. So now we are going to present about our design PLC ladder programmings for the fluid flowing process control. So the software that we use is called as OpenPLC editor. So so here is our PLC ladder programmings. So for the first connections, here's a X1 indicates the start buttons connected to the relay and connected to the solenoid Y. So for the next one is a switch, and here is the flow switch which detect the level of the water and connect to the relay ones. Here's the timer 1, relay 2, in order to control the timer 2, relay 2, and as well as the solenoid 2. So the time for the first timer is about 120 seconds, and for the second one is about 90 seconds. So now we start the simulations. Okay, here's the conditions that after we start the simulations. So by following the operations, we will force through the switch, which is the start button is switched on. You can see that the solenoid line is energized, so which allow the valve and the fluid flow into the tank. Now next, when the water level is become full, the flow switch will be activated. So the solenoid 1 will be de-energized, and the timer 1 is start to count about 120 seconds. Okay, now it's about the 120 second delay for cycle chemical reactions to occur in the tanks. So at the end of the delay time, the time will energize the second relay C2. So the second relay will be energized, and which control two devices in the initial timer, which start to count 90 seconds to allow the contents of the tanks to be drained. And the second, here is the solenoid 2 is energized. So we have to wait about 90 seconds in order to de-energize the solenoid 2. Okay, after 90 seconds of the countings, so we can see that the solenoid 2 is de-energized, which closing the outflow valve. So now we depressing the X1 in order to reset the timers and opens their respective contents. So here's the here's the situations of the reset the PLC diagram. So that's all for the operations and the design of the PLC ladder diagram for the fluid flowing process control.
Greetings, Doctor. My name is Shankar ANAK SUBRAMANIAM, matrix ID AE190090. So from the previous section, we saw Tan demonstrating the PLC circuit, and for this part, this is the truth table where there's an input and output. So the first table, it shows X1 and relay 1 and S1 solenoid 1. So when X1 is 0, relay is 0, it switches to 0. When X1 is 1, relay is 0, it doesn't open. If X1 is 0 and relay is 1, it doesn't open, and if both of them are on, it will open. As for the next one, we are using the timer where if both is not activated, the solenoid 2 will not activate. If both of them are activated, the solenoid 2 will switch on. As for the last table, there's a float switch to indicate the tank is full, and also the relay one, where both of the switches needs to be activated for it to not activate solenoid 1. So this will allow to switch off the solenoid 1 to stop the water from coming in. So this pretty much sums up the table. Thank you.
Hello, my name is Recher. So I'm going to explain to you the value safety and economic aspects that we taken into consideration in our design. So first one, X1 button will not switch on when tank button is on. So as you can see, tank button is the float switch. So when the water is already in a high level, it will off the X1, and it will allow the chemical reaction to be combined for 120 seconds delay, and after 120 seconds delay, it will charge the relay 2, which will turn on the time taken for 90 seconds, where it will drain the tank. So after it drain the tank, so the tank button on indicates that the system is full, and tank button will reset after S2 is open, which will allow the S1 usable. After 90 seconds, it will discharge, and it allow the X1 over here to be used again, so the water can be flow into the tank again.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurima bin Barin, and I will present about the approaches to achieve cost-effective operation. So first is tank button immediately closes solenoid 1 after 90 seconds to prevent any wastage of fluid. And the second is after the tank is drained, the whole system resets immediately to avoid any wastage of power. So okay, this is the PLC circuit, the example of PLC circuit. So we can see here we have a 90 second here, and the switches. Then the second circuit is after the tank is drained. So that's all from me and from us. Thank you.